Hello everyone, today let us discuss about gel filtration using Sephadex. First, let us come to introduction. Gel filtration chromatography, also called size exclusion chromatography, gel permeation chromatography, molecular sieve chromatography, is a technique used for separating chemical substances by size based upon their migration through a stationary bed of a porous semi-liquid substance, that is gel. The method is very useful for separating enzymes, proteins, peptides and amino acids from each other and from substances of low molecular weight, example salts and enzyme cofactors. Small molecules diffuse into the interior of the porous stationary phase particles so that their flow is restricted, while large molecules are unable to enter the pores and tend to flow unhindered. Thus, the components of highest molecular weight leave the bed first, followed by successively smaller molecules. The separation of molecules is called fractionation. Size of pores in beds determine the exclusion limit. The bed materials most extensively used are agarose, polyacrylamide, that is biogel, and a polymer prepared from dextran and epichlorohydrin, that is Sephadex. Now let us come to separation of hemoglobin potassium dichromate mixture on Sephadex. First, let us discuss the principle. Gel filtration is performed using porous beads as the chromatographic support. A column constructed from such beads will have two measurable liquid volumes. The external volume consisting of the liquid between the beads and the internal volume consisting of the liquid within the pores of the beads. Large molecules will equilibrate only with the external volume, while small molecules will equilibrate with both the external and internal volumes. A mixture of proteins in a discrete volume or zone at the top of a gel filtration column and allowed to percolate through the column. The large protein molecules are excluded from the internal volume and therefore emerge first from the column, while the smaller protein molecules which can access the internal volume emerge later. The dimensions important to gel filtration are the diameter of the pores that access the internal volume and the hydrodynamic diameter of the protein molecules. The latter is defined as the diameter of the spherical volume created by a protein as it tumbles in solution. Proteins whose hydrodynamic diameter is small relative to the average pore diameter of the beads will access all of the internal volume and are described as being included in the gel matrix. Proteins whose hydrodynamic diameter is comparable to the average pore diameter will access some but not all of the internal volume and are described as being excluded. Proteins whose hydrodynamic diameter is large relative to the average pore diameter will be unable to access the internal volume and are described as being excluded. This conceptualization has led to the gradual renaming of gel filtration as size exclusion chromatography. The order of elution of a mixture of proteins from a size exclusion column will then be the inverse of their hydrodynamic diameters. If all the proteins in a mixture are known or can be assumed to have the same shape, then the order of elution will be the inverse of their molecular weights. Higher molecular weight fraction eluted first because high molecular protein do not enter the beads. Small size proteins enter the beads and get eluted in the last out of the column. Gel filtration chromatography is used in enzyme purification and characterization of antibodies, separation and purification of peptide and protein hormones. Gel filtration chromatography can be applied to separate a wide range of molecules according to size, including proteins and enzymes, polysaccharides and nucleic acids. There are two major categories of gel filtration chromatography, that is group separation and fractionation. In group separation, samples are separated into two major groups, for example, in desalting to remove salts and other low molecular weight contaminants. A resin is chosen that excludes larger molecules from the pores of the beads, while smaller molecules are retained in the bead and then eluted. Fractionation is used for the separation of macromolecules of different sizes. The fractionation range of the resin defines the range of molecular weights that should be separable. Typical applications of fractionation using gel filtration chromatography include preparative purification, analysis of aggregates, and molecular weight determination of proteins, peptides, and nucleic acids. The advantages of gel filtration chromatography are short time analysis, well-defined separation, narrow bands, and good sensitivity. There is no sample loss, small amount of mobile phase is required, and flow rate can be set. However, the disadvantages of gel filtration chromatography is that only limited number of peaks can be resolved within the short time scale of the gel filtration run. The molecular masses of most of the chains will be too close for separation to show anything more than broad peaks. Now let us come to materials required. First, hemoglobin, then potassium dichromate, Sephadex Z50, sodium chloride, sodium dihydrogen orthophosphate, sodium hydroxide, chromatography column 20 into 1 cm, spectrophotometer, pipettes, cuvette, and pH meter. Now let us come to procedure. First is preparation of elution buffer, that is 0.05 molar phosphate buffer of pH 7. 3.9 gram of sodium dihydrogen orthophosphate dihydrate and 4.5 gram of sodium chloride is dissolved in 300 ml of distilled water. pH of this solution is made up to 7 with sodium hydroxide solution. After this, the volume of the solution is made up to 500 ml with distilled water. Next is taking of chromatography column. Add 4 gram of Sephadex Z50 in water or buffer solution and leave it for 3 hours to swell. Stir the solution gently with a glass rod occasionally and decant off any particles in the upper layer. Pour these contents into the column with the help of a glass rod and prepare the column of 18 into 1 cm length. Allow the beads to settle under gravity while maintaining a slow flow rate through the column. Continue the flow of the buffer through the column so as to equilibrate it. Use a large volume of solvent relative to the amount of the gel to avoid trapping air bubbles in the column. Next is preparation of sample. 5 gram of hemoglobin and 5 gram of potassium dichromate is dissolved in 500 microliter of distilled water, and the final volume is made up to 1 ml. The solution now has a concentration of 5 gram per ml of hemoglobin and potassium dichromate. Now let us come to experimental procedure. After equilibrating the column, the tap is turned off and allow the solvent to touch the top of the column and load 0.5 ml of 5 gram per ml solution of hemoglobin and potassium dichromate onto the column. The column is eluted with the buffer solution. 2 ml of the fractions eluted are collected continuously until potassium dichromate is eluted. The absorbance or extinction of the fractions are measured at 550 nanometer and 440 nanometer wavelength in a spectrophotometer. Wavelength of maximum absorption for hemoglobin is 550 nanometer and wavelength of maximum absorption for potassium dichromate is 440 nanometer. The buffer solution is taken as blank. A graph is drawn by plotting the volume of fractions eluted in the x-axis and the respective absorbance of the fractions at the respective wavelength. This is the elution profile or separation curve of hemoglobin and potassium dichromate. Now let us come to observation. This experiment illustrates how gel filtration separates molecules by reason of difference in their size. From the elution profile, we can observe that hemoglobin elutes before potassium dichromate. Hemoglobin is the iron-containing oxygen transport metalloprotein in the red blood cells of all vertebrates. It has a molecular weight of 66,000 Daltons or 66,000 gram per mole. Potassium dichromate has a molecular weight of 294.185 gram per mole. The compounds are both colored, so the progress of the filtration can be followed by observing the separation of the colored bands. Thus, it can be proved that in gel filtration chromatography, molecules separate according to their molecular weight. Molecules whose molecular weight is high elutes first, and molecules with a small atomic weight elutes last. Therefore, hemoglobin whose molecular weight is greater than potassium dichromate elutes out before potassium dichromate. Now let us come to conclusion. Gel filtration chromatography separates proteins, peptides and oligonucleotides on the basis of size. Molecules move through a bed of porous beads, diffusing into the beads to greater or lesser degree. Smaller molecules diffuse further into the pores of the beads and therefore move through the bed more slowly, while larger molecules enter less or not at all and thus move through the bed more quickly. Both molecular weight and three-dimensional shape contribute to the degree of retention. Gel filtration chromatography may be used for analysis of molecular size, for separation of components in a mixture, or for salt removal or buffer exchange from a preparation of macromolecules. Thank you.